Hi class, we're going to look at Python while loops now. A while loop is a condition controlled loop. This contrasts with a for loop, which is a count controlled loop. So we'll use a for loop anytime we know the number of iterations that we need to do. We can use a while loop when maybe we're not sure how many iterations we will ultimately do, but some condition will be met. And at that point, our loop will stop. So while loops need some type of a condition, some type of an expression, there we go. I think my connection hiccup for a little bit. We need some type of expression in order to stop the loop. Otherwise, we'll end up in an infinite loop if the expression never changes. Now, our syntax for that is nice and simple. It's just going to be a while expression. An expression is going to be some type of mathematical or logical expression that we can use to control this loop. So let's say we want to, we'll keep going in a loop as long as the user inputs a number less than 10. Why don't we do that? Let's see how we could possibly code that. So we'll use this while loop structure here. And we can just say, well, conversationally, we just described it. As long as the input is less than 10, then we'll keep going. So that expression would look like while input is less than 10. And then we would just code whatever we want to happen inside that loop. So for example, I'm first going to get the loop going to start, let's go ahead and create the input variable, and let's initialize it to 0, just so that we enter the loop, one time. If we initialize this, to, let's say 100, well, then our while loop would never execute because input here is greater than 10, so we would never enter the loop. So I'll just initialize it to 0 for now. Now then, inside our loop, well, let's just say, okay, let's just instruct the user to enter a number less than 10 to keep the loop going. Well, let's not use input, let's use entry, since, of course, input is a reserved keyword. So let's go entry here. We'll cast that. We'll give our prompt here. And I'm going to just kind of continue on here on the next line because I'm running out of space here. Enter a number less than 10 to keep going. Something like that. And we'll see that this will just kind of go and go and go and go until the user finally enters a number that is greater than 10. So it's just sort of a silly example, but let's turn to the code now and show how we can see this in action. Here in our Jupyter Notebook, I've got the code sketched out, and this entry line here is simply going to present this prompt to the user, enter less than 10 to keep going. It's going to retrieve that input from the user with the input command. It's going to cast it or convert whatever was input to an integer. And then it's going to assign that value to entry. So let's run this. And we get the prompt enter less than 10 to keep going. So I'll just start to enter some numbers that are less than 10. And now finally, I will enter 1,000 and the loop stops. So this is typical while loop behavior. Once we got the last 1,000 entered here in that last iteration, then we go back to the top of the loop and the expression is evaluated again to see if we continue. So is entry currently less than 10? And when we entered that 1,000, that while loop expression turns false. Entry less than 10 is false, and therefore the loop stops. Now here's a few other while loop examples that I wanted to include here, and let's go over these real quick. Here's an example of a variable called keep going. And we can just simply ask the user for a y or an n if they want to keep going and can continue to perform some type of an operation or not. So here, I have just got 1 + 1 = 2 output. I mean, it's a silly example, but it's going to just demonstrate the mechanics of this. I've got the keep going variable initialized to y. And the while loop is saying, all right, as long as keep going stays a lowercase y, then we're going to stay in this loop. Inside the loop, our first task is to print out the phrase 1 + 1 = 2. But then look what we do. We ask the user, hey, do you want to display this again? Yes or no? And whatever they enter is going to be, first of all, converted to lowercase character, and then assigned to keep going. So when we run this, we'll see that we're getting this output here now. Dave, do you want to display this again? And sure, I would love to. So there I'm entering a lowercase y and it kept going. Here I'm entering an uppercase y and it kept going. And I'm finally going to enter an n. Now, if you saw from the other video, .lower is a great method to take an input string or input character and convert it all to lowercase. That way, up here in your test expression, all you have to do is test for that lowercase. That's going to be the easy path for testing for lowercase. It gives the user a little more flexibility. They can go ahead and enter an uppercase. Maybe their caps lock was on, or they're used to typing in capital Y's. And it doesn't matter, because you're going to just convert it to a lowercase anyway and test against that. Now, here's another little snippet of code. It is going to output that same extract that we saw in the last video, the extract of the 6th row from the times table for our multiplication tables. And we'll print out as many as the user wants, and we'll stop when they tell us to stop. Pretty simple. So we'll have a keep going variable, just like we did in the last example up there. I'm going to have an index variable here because I'll need to store a number in it. Because we're going to go, 6 times something is 0. 6 times 1 is 1. 6 times 2. So we need that 0, 1, 2. We need that index. So I'm going to create a little index variable there just called I, and I'll set it equal to -1. That'll make sense here in a minute. Then inside our while loop, as long as keep going stays a lowercase y, then we'll continue. The first task that we perform inside that loop here is we're going to increment I by 1. That's why I initialized I here to -1, so that the first time through the loop, we're going to add 1 to it. It's going to give us 0, and then we can use 6 times 0 = 0. Now this combined assignment operator here, plus equals, is the same thing as I = I + 1. That's just going to increment I as a counter variable. It's just going to increment it and increment it by 1. Now then, let's take a look at this print statement. It's going to print this F string here that's highlighted. And let's take a look at what that is. It's going to say, okay, print out 6 times, and then whatever I is currently, and then the equal sign. And then we'll have a math expression in those braces, 6 times I. So it'll print out the current row of the times table that we're kind of traversing. But then let's ask the user, hey, do you want to see another one again? So parsing this, it's going to display this prompt to the user. It's going to capture that input. It's going to convert it to lowercase here with .lower. And then it's going to take all of that on the right-hand side of this equation and assign it to keep going. So it's going to update keep going with what the user had just entered. So let's run this now. And we'll see here, we got the first 6 times 0 = 0. Let's enter a y for the next one. And we got the 6 times 1. I'm going to add enter an uppercase y. We got 6 times 2. Let's do another couple until finally I'm going to hit anything other than y will stop that loop, including an n. And you can see here how we got the times tables then all printed out. Now, it was necessary to make sure that we increment I every time through this loop, so we get the ever increasing series of numbers that we're multiplying against 6. All right, I hope that this helped explain while loops, and please make sure to code these and practice with them. Try and break them, try and change parameters around, and this should set you up nicely for the lab.